So let's practice with some mass-to-mass stoichiometry. So let's look at this problem. We're considering this chemical equation where we react calcium phosphide with water to form pH3, which is phosphine, and calcium hydroxide. Before we begin, let's check to make sure that the equation is balanced. On my reactant side, I have 3 calciums. On my product side, 3 calciums. On my reactant side, 2 phosphorus. On my product side, 2 phosphorus. On my reactant side, 12 hydrogen. So 2 times 3 is 6, plus 3 times 2 is 6. 6 plus 6 is 12 hydrogens. And lastly, let's take a look at oxygen. I have 6 oxygens on my reactant side, and 3 times 2, 6 oxygens on my product side. So it's balanced. Alright, so we're given 100.0 grams of water and sufficient calcium phosphide. How many grams of phosphine, pH3, will be produced? Alright, so we know that this is a mass-to-mass stoichiometry problem because I'm giving mass of one chemical, water, and asked to find the mass of a different chemical, phosphine. And these two chemicals are related to one another through this balanced chemical equation. So I'm going to have you stop this video and figure out the answer to this, but first I want you to remember that the conversion factors are going to be the mole ratio of the desired chemical to the given chemical, as well as the molar mass of both the given and desired chemical. So you can go ahead and stop this video and work on this, and when you get the answer, we'll go over it. Okay, so when I solved this problem, I wrote out the balanced chemical equation at the top of my page so I could keep track of it. And I wrote out what information I was given, the 100.0 grams of water, and what I was looking for with the gram of phosphine. So in any stoichiometry problem, we will always use the mole ratio, which will be the moles of the desired chemical to the moles of the given chemical. So in this case, we're given water, so 6 moles of water goes in my denominator and 2 moles of phosphine goes in my numerator. And I want to remember that my mole ratio will always have the labels of mole, the chemical formula, and the stoichiometric coefficients from the balanced chemical equation. So that's how we get our mole ratio. And then since it's mass-to-mass stoichiometry, I'm going to need the molar mass of both my given chemical and my desired chemical. So I calculated those. 1 mole of water has a molar mass of 18.02 grams of water, and 1 mole of phosphine has a molar mass of 34 grams of phosphine. Now remember, when you calculate the molar mass, it is always 1 mole. 1 mole. It doesn't matter what your stoichiometric coefficients are. You take into consideration those stoichiometric coefficients from the mole ratio. The molar mass is always, always, always 1 mole. Alright, so I'm going to do a quick double unit check before I do my railroad math. Grams of water, grams of water. Grams of phosphine, grams of phosphine. Moles of phosphine, moles of phosphine, moles of water, moles of water. Every unit in my given, my wanted, and my conversion factors shows up 2 times. So that means I can do my railroad math and everything will cancel out. Okay, so here's my setup for my railroad math. We always begin with what we're given, which was the 100 grams of water. And then in mass-to-mass stoichiometry, I need to convert my mass of given chemical to moles by dividing by the molar mass. So I see my grams of water cancels out. Then I have moles of water. After I convert my given chemical to moles, then I multiply by the mole ratio. The given chemical is always in the denominator, and that way moles of the given chemical will cancel out. Then I have moles of my desired chemical. Now the only thing is it's mass to mass, so I want to get this mole of my desired chemical to mass by multiplying it by its molar mass. So when I do my math, and you can do that by multiplying everything in the numerator and then dividing it by the product of the denominator, I just multiply 100 by 1, divide by 18.02, hit the equal sign. Multiply by 2, divide by 6, hit the equal sign. Multiply by 34, and of course dividing by 1 won't change the value. So I get 62.89 grams of phosphine. If you get that, give yourself a pat on the back, and you're on the road to really getting mass-to-mass stoichiometry.